Hello everyone, I hope you are doing well. So in today's video, we are going to go through the 2024 Northern Hemisphere Methods Exam 2 of the multiple choice section. Like always guys, before I start this video, if you guys want private tutoring in specialist methods, physics or chemistry, you can always email me through this email. So for this paper, I am going to take it very slow because I want to be as detailed as I can. Because, Vika hasn't basically, posted the solutions for this. So again, these are suggested solutions. If you guys see a mistake, please let me know. And yeah, I'm going to try to be as detailed as I can. I'm going to try to do it all by hand and some by CAS. Now, normally you can do this by CAS in a second, but I want to be as detailed as I can so students that don't really understand the concepts can really get it through visual learning. So absolutely, let's smash this paper. Question 1. The period and range for the function f of x, this, are respectively what? So we've got a sine function here. Remember, for period for both cos and sine is p equals 2 pi n, where n in this case is what? It's 2. It's the constant that's in front of x. So your period is pi. So that is your period. So let's look at the answers. So B is wrong, D and E. So it can only be A and C. Now, how do you find the range? There's actually a quick trick to do it. What you do is you draw some square brackets. You always do, square brackets. And it's always your translation first. So negative root 3. And you're always going to write minus your amplitude, root 3. And then you do the opposite on the other side. So again, minus root 3 plus the amplitude. So basically, for the first one, you minus. For the second one, you basically plus. So basically, that's going to simplify to negative 2 root 3 and 0, which basically gives me C. Now, you can do this by basically CAS. You can graph it and see what it is. But yeah, that's how you do it by hand. I think doing it by hand is much quicker for this question. So let's do question 2. For two independent events, A and B, it is known that the probability of A is that and the probability of A union B is that. Then what's the probability of B? Because we know they're independent. This is the formula for independency. They have to meet this condition where the probability of A, so probability of A intersection B must be equal to the probability of A times your probability of B. If they are independent. In this case, they are independent. So what is A? We already know A is 0.6. So you can actually write this as 0.6 and put this right in here. Right there. Now, if we have A union B, the thing that reminds me is the addition rule. So that should remind you of the addition rule. So the probability of A union B is equal to the probability of A plus the probability of B minus the probability of A intersection B. And so we know that the probability of A union B here is 0.92. We know the probability of A is 0.6. Plus the probability of B minus your probability of A intersection B. Now we already have that, don't we? It's this here. So minus 0.6 probability of B. And we got a nice algebraic function here that we can solve. So I'm going to bring this 0.6 to the other side. So 0.32 equals, then what's the probability of B minus 0.6 probability of B? It's basically going to leave us with 0.4 probability of B. Divide both sides by 0.4. That's going to leave me with my probability of B, which is, you can write it as 32 on 40, which is 4 over 5. So choose A. Now, you could do this by CAS, basically. Get this here and sub that into their CAS and it'll solve it for you. But yeah, that's how you basically do this question. Question 3. Let's have a look at this. The positive real number A and B and C are satisfy this equation. Therefore, it must be true that. So they're all saying A equals. We're basically solving for A. Now, let's do that. Let's solve for A in here. So what I'm going to do basically, you can see that two logs are being added and they basically have the same base. So let's, what happens if you add two logs? They multiply, the insides multiply. So it's going to be log 5AB is going to be equal to 2 log 5C. Now, we also have another property. The two the two that's, the constant that's in front of it can actually be put as a power. for the c here. So it's c squared. So it gets rid of it. We can get rid of it. Now, by equality, we know that these insides must, because you know how there's a log 5 equals log 5? These here must equate. They must be equal. So doing those, so AB must be equal to c squared. And so hence A is equal to c squared over B, which looks like D. Now, there's so many ways you can do this. If I'm in the exam, to be honest, I won't do this. If I'm in the exam and I don't have a lot of time, I'm going to do the quickest way, which is basically understanding that it says the positive real numbers A and B satisfy this equation. So they have to be positive numbers. I'll just make up values. So I'll say like A equals 2, B equals 3, and actually put them all into this equation and solve for C. And so when I solve for C, I'm going to come back here and I'm going to try those values here. And which one makes sense? Which one's going to be true? That's the one that I'm going to pick. So that's, yeah, it would be D. But that's how you do it algebraically. Next question. Question 4. A straight line passes through the positive x-intercept of the curve of the cubic y equals x to the power of 3 negative x squared that, and also through its point of inflection. The gradient of the line is what? So what I'm going to do is just graph it on my CAS and kind of show what it looks like. Represent this. So let's go on our CAS. So it is x to the power of 3 minus x squared minus 2x. Graph this. This is what it looks like. So what is our x-intercepts and stuff? So go analyze 0. So 2, of course, the other one's 0, and the other one is -1, so it looks like that. And remember, we're saying it passes through the positive x-intercept, which is basically this 2 here, and also through the point of inflection. Now, the point of inflection is going to basically occur here, which you can easily find going menu, analyze graph, inflection. There's the inflection point here. So, but we don't want it in decimal places, so we want to actually solve for it. One of the quickest ways to find the point of inflection of a function is actually to find the double derivative and let it equal to 0. And so that's what we're basically going to do. So let's go in our CAS and go. So, sorry. To get the double derivative, you press this over here, double derivative, and that's f1 of x in this case, equals 0. And we solve answer, comma, x. So basically, the inflection point occurs at x on 1 on 3. Now, of course, we want the y value too. So subbing it into our original function, we get -20 divided by 27. So I'm just going to graph this on my, all this information, I'm just going to basically put it in my iPad. And so let's look at it through there. All right, so let's have a graph of the function that we've seen. It's going to look like this, basically. This is your x, this is your y. Okay, so it passed through -1, and it passed through 2. So if I just pass through 2, and also 0. It's going to go like, basically, it was going like this. That, like that. There it is. Okay, well, basically this here is 2, 0. This one's 0, 0, then that's here is -1 on 0. And we found that the point of inflection, which basically occurs over here, around here, is the coordinates was 1/3. So looking on my thing, what was it? 1/3 -20 over 27. Beautiful. So what I want to do is I want to find the gradient of a line that passes through these two. This point over here, the point of inflection, and the positive x-axis. So x value. So if I draw like a line, just a nice line here that passes through these, basically I need to find the point. I need to find the gradient of this line. That's what we want to basically find. How do we do that? Well, we have 2 points. We have this point over here and this point on the graph, so we can use our y2 minus y1 formula. So the gradient is basically y2 minus y1 over x2 minus x1. So y1 in this case is, we're going to say -20 divided by 27 minus 0, all being divided by 1 on 3 minus 2. So putting this all on my calculator to do that, I should get my answer. So that's going to be -20, 27, 1 over 3 minus 2. And so that gives me 4 over 9. So the answer is 4 over 9. So which one looks like that? Looks like A is our answer. Beautiful. Next question. Question 5. says when a biased coin is tossed, the probability of the coin landing on a head is this. The coin is tossed 10 times and the number of heads is recorded. The probability that exactly X heads are recorded is what? What a beautiful, easy question. So we know this is a binomial distribution. So let's write it down. So we know that basically X is going to be binomially distributed, where what is the number of like trials, which in this case is it's tossed 10 times, and the probability of success, which is 0.25. Now, if we want to basically find the probability that exactly X heads are, so something like X equals X, remember what the formula is. It's going to be your N choose X times the probability of success to the power of X times your probability of unsuccess to the power of N minus X. So in this case, our N is 10. So it's going to be 10 choose X times the probability of success, which is 0.25, to the power of X, times your probability of unsuccess, which is 0.75. So it's going to be N minus 10. Well, we know N is 10 minus X. So it will look like this. So also, that 10 choose X can be also written as this. So 10X. So 10 choose X, basically. It's the same thing as 10 choose X, like that. So it doesn't matter. They're basically the same. So if you're kind of confused, yep. So let's just replace it for the sake of this answer. 10 X, there it is. So that is it. That is our answer, which looks like it is, looks like B is our, B our answer. Question 6. The graph of y equals tan AX has the asymptote with the equation here. A possible value of A is what? Now, this is actually quite easy because think about it. Now, you got 5 possibilities of what A is. Now, the easiest way is to just sub them in. And so, like, for example, say that we sub in the first value, which is 4. So our A is 4. So it's going to be tan 4x. You should realize that if you sub in, if it's an asymptote and you sub in that x equals pi on 6, the y value should be undefined. Remember, because an asymptote, it should be undefined. So if I sub the pi on 6 into it, and if it gives me a real value, then it's not an actual, it's not the equation, it's not the true value of A. So it has to tell me for it to be an asymptote, it's supposed to only tell me if it's supposed to say that it's undefined. So for example, this case here, if I sub in pi on 6, this here will become 2 pi on 3. And that here is basically equal to tan pi minus pi on 3, which is basically negative root 3. Look at that. That is a real value. It's not undefined. And so you basically do this. Now you don't want to do this by hand. You don't want to do that for every one of them. You can do this in CAS in a second, and that's what we're going to basically do. So let's actually write the equation. Tan 4x, so tan AX, sorry. Given that x is equal to pi on 6, and A equals, let's try the first case that we just did, which was A equals 4. And look at that. It gives me a value. It's not saying it's undefined, so that's not the answer. What about to try the B, which is saying 6? Still, 0 is not undefined. Try the next one, which is 9. Jackpot. We hit the undefined. So this is an actual asymptote. So when A equals 9, it is an asymptote. So 6 is C. Choose C. Question 7. The function f of x, a cos x, has a period of pi on 3 and a maximum value of 10. Given that b has to be greater than 0, the minimum value of the function f is what? Okay, that's not too bad. So, if we're given that the period is pi on 3, we know that period for like a cosine is 2 pi n, where in this case, our n value is b minus 1. So, b minus 1. Well, we know the period is pi on 3. And we can see that pi's on both sides, so we can cancel those pi's out. And I'm going to cross multiply them. So I'm going to cross multiply this here and cross multiply that one there to simplify it. So it's going to be basically b minus 1 equals 6. So b equals 7. So we already found our b value. But we also know that the maximum value occurs at 10. Now, how do we find the maximum value? It's quite easy. It's just b plus a. So your maximum value is b plus a. And our minimum value should be b minus a. It's the range. And so if we know this max value here is 10, and we know already b is 7, a has to be equal to 3. So we basically have a equals 3 and b equals 7. So to find the minimum value of f, which is here, it's basically going to be equal to b, which is 7, minus a, which is 3, which gives me 4. So choose 7b. Beautiful. Question 8. When entering a zoo, visitors are asked how many times they have previously visited. The discrete random variable n with the probability distribution shown below can be used to model the number of times each visitor has previously visited. Okay, so alright. So basically, like, say a person goes into the zoo and say the person that's, like an employee tells them, hey, is this your first time coming here? If they say yes, it means they've never came previously. So our n would be 0. But if someone came in there and they asked the same question, but he's like, yeah, I've been here previously once actually. I came here last year. So that is 1. Say someone else says, I've been here twice. That's 2. So it's the previous time, not the current time, but the previous. All right, so it says given, just that word gives you a hint. It's given. Given is conditional probability. Do not forget that. When this says given, they're giving you a hint. They're giving you extra information, which is conditional probability. Given a visitor has previously visited the zoo, what is the probability that they have previously visited more than once? All right, let's write that down. So we want to find the probability of what? So we want to find the probability first, that they have previously visited more than once. So we basically want where n is greater than 1. Because what is the probability that they have previously visited more than once? Yeah, so basically when n is greater than 1. Given, so it says given that a visitor has previously visited the zoo. Now, if they previously visited the school, it's only going to be these ones over here. 1, 2, and 3, because they basically previously came back to the zoo. The person at 0, this is his first time coming here, but these have basically previously been. So it's basically where x is, sorry, why am I writing x? Where n is greater or equal to 1. All right. And so we're going to find now using your, simplifying your, conditional probability, we know that's going to be, let's see here, n is greater than 1. Can be just written as n is greater or equal to 2, just to be simplified. So probability of basically n is greater or equal to 2 intersection n is greater or equal to 1, all being divided by the probability that n must be greater or equal to 1. Beautiful. How do we simplify this inequality? We can actually do that by just drawing a number line. So let's draw this nice number line here. So let's actually draw let's say this is your 1 and this is 2. So it says greater than 1, so an ink circle goes to the right forever. And 2 is greater or equal, so it's going to be a closed circle and goes there. So when do they intersect? They intersect here, where this basically simplifies to the probability that n is greater or equal to 2, all being divided by the probability that n is greater or equal to 1. We are nearly done. Perfect. Now this is quite easy to simplify because the probability that n is greater or equal to 2 means these probabilities here have to be added, these ones over here. So let's add those up. So 0.25 plus 0.15 plus 0.05. And the probability that n is greater or equal to 1 is this over here, these probabilities. But we can actually just kind of shortcut that. We don't have to add them because we know that the probability that this one here, the one that's left out is 0.25. It's 1 minus that 0.25. It's going to be 0.75. So basically these here, if you add them, they should be equal to 0.75. Because you just say 1 minus this, and you get overall these here. And so yes, let's put this in our calculator and see what it gives us. 0.25 plus 0.15 plus 0.05. 0.75. Enter, and that gives me 3 over 5, which control enter that gives me 0.7. So our answer is 0. So what am I saying 0.7? 0.6, which is B. So for question 8 is B. Question 9. Let f of x be this function. So it's a parabola and it's a minimum because you can see it's a positive. Our a value is positive in this case. Not our a value, not this a value, but a constant in front of it, it's positive. So it's a minimum parabola where a is an element of all reals. The set of values of a such that f of x is greater than 0 for all x as an element of all reals is what? Okay, let's have a graph of it. Let's actually visualize this. Okay, so if I just nicely graph this, say this is your x and this is your y. So let's draw this parabola. We know it's a minimum parabola, and it could be anywhere. So this is, for example, let's say it's like this. Okay. If we want f of x to always be greater than 0, meaning that it has to be above the axis, so like always above the x-axis, not equal to it, not on it, because that's then f of x is greater or equal to 0, but always above it. What really makes it that? It really is all about that turning point. The turning point's y value, so let's say it's x and y. That turning point, the y value must be greater than 0, because if the turning point's y value is like 3, which is positive, then this whole thing gets shifted up like that. But if your y value is negative, it means then the parabola is, not greater than 0. So for it to always be like, f of x to be greater than 0, the y value of our our turning point must be greater than 0. So to always make sure it's always above the x-axis. So let's do that. We just need to find the y value of our turning point. Now that's quite easy because you can find the what we call the turning point by, okay, first to get the turning point we need to derive f of x. I mean you can do this all by CAS, but I do want to do it by hand to show students that don't not very strong in these kind of conceptual understanding. So f dash of x is equal to 6x minus 2a. And I'm going to let that equal to 0. Remember, you let the f dash of x equals 0 to find a stationary point. So x6x basically equals 2a. X is equal to a on 3. So basically the x value here is xa on 3. Now to get the y value, you just sub it back to the original function. So f of a on 3 as well. That's going to give me 3, so a squared on 9 minus 2ax, which is a on 3, plus 6. Beautiful. So that's my y value, so I'm going to simplify it. So that's going to be a squared on 3 minus 2a squared on 3 plus 6. So 1 minus 2. So it'll be negative a squared on 3 plus 6. Beautiful. So this is the y value. Now, what did we say? We wanted the y value to be greater than 0. So we want to solve this to be greater than 0. So that's going to give me negative a squared on 3 greater than negative 6. Multiply both sides by 3. We get negative a squared is greater than negative 18. Divide both sides by negative 1, but be careful. If you're dividing by a negative number, the inequality sign changes. So it'll be less than 18. And hence, let's, what is this going to simplify? So imagine this is your parabola. Let's draw the parabola. And this is your parabola. It looks like this. Oops. And really, why is it not nicely drawing? It normally does it. Come on, if it's not going to do it. All right, we don't. Okay, who cares about that? Okay, so say this is your parabola, and you draw the line y equals 18, which is around here, let's say. When is this here, basically this here, which is the parabola, which is that yellow, and that purple, which is that 18. But what this is saying is when is the yellow graph less than 18? Well, it's actually less than 18 over here, in these parts over here, which is basically, we know these y values basically are what? This is going to be, when you solve this, what do we get? We should get 3 root, so negative 3 root 2, and this value here is 3 root 2. So basically, the values for which a squared is less than 18, so when you solve this, you can solve it with a CAS in a second, but visually or by hand, you do this. So a is going to basically be this domain, so it's going to be from negative 3 root 2 to 3 root 2, and make sure they are not equal, because if it's equal, then this is telling us it's not equal, so less than 18. Beautiful. So which one looks like that? Looks like D is our answer for that one. Beautiful, 9D. Next question. Question 10. Let's have a try this. The graph for y equals f of x is shown. Okay, find the value of k given that f of x is a probability density function. Easy. So we know a probability density function, the area under it must be equal to 1. Remember, the area represents probability. So, and remember, the total outcome of all probabilities must be equal to 1. So basically meaning that this whole area under this whole graph must be equal to 1. Now I'm going to make my life easier. Because of symmetry, this here should be equal to a half. Because remember, this here is all equal to 1, so this has to be half, and also this has to be half because of symmetry. Now I'm just going to say this here. I'm only going to be focusing on this half here. Now it is the area, so you can see it's a trapezium. So how do you find the area of a trapezium? We know the area of a trapezium is this formula, half a plus b times height. Well, in this case, our a is going to be from here to here, a. In this case, our b is from here to here. And our height is the height of that trapezium, which is this over here. That's our height. So putting this, remember, area is half. We know the area of this whole thing here is a half. So it's going to be half equals half a. Our a is what? It's from 0 to, it's basically 2. So 2 plus b, which is k, times your height, which is also k. So these halves basically can cancel out. So it will be left out of 1 here. And expanding that out, you get basically k squared plus 2k, which is basically k squared plus 2k minus 1 equals 0. And we solve this, and we should be able to get our value. So let's use our CAS to solve this. So solve k squared plus 2k minus 1 equals 0, comma k. And so these are our two solutions. So let's write those down. K equals negative root 2 minus 1. And k equals root 2 minus 1. Let's get one thing right. This here is negative. And we know k cannot be negative. You can see that k is positive. It's on the right side. So k has to be positive. So it can only be this one over here. This is wrong because it's negative. So reject this one here. Reject it. So reject that one. So you should get k equals root 2 minus 1, which is a. So 10 is a. Next question, question 11. In a certain location, the number of hours of daylight per day is modeled by this. So it's per day. So h of is this, where t is an element of all integers plus. Be careful. So what that means is t equals 0 is not included. It's saying it's plus. So like it could be t equals 1, 2, these are your values, not like 1.1. It's always whole numbers, integers. 1, 2, 3, 4, like, you know, and going forever, basically. Now, where t represents the day of the year, and so we note that t equals 1 represents the 1st of January. Okay, so it represents the first day. According to this model, note that t equals 1 represents the 1st of January. According to this model, during one year of 365 days, the number of days for which there is at least 11 hours of daylight is what? So wait. It's just I think I'm so confusing with the wording here. Where t represents the day of the year. Note that 1 year, so note that when t equals 1, it represents the 1st of January. Okay. So t equals 1 represents the 1st of January. I don't know if I'm losing my mindset here, but wait. So when t equals 1 represents, so t equals 2 represents like the 2nd of January. Okay. Because you know how t equals 0 doesn't, normally your questions you get is like, normally you start with t equals 0, which is the initial, and then you go to 365 days. But here, we're going from t equals 1. So is our like, so according to this model, during one year of 365, so we're going from, like, if you add 365, are we doing this basically? Like, I don't know if I'm wording this in my mind wrong. So are we saying like, so we're going from 1, so t equals 1, the domain, to like 365, but it's 366 because this one is already included. So like, for example, yeah. So you're starting at t equals 1, so that's your domain here, 1. And you're going, imagine adding 1 year, which is 365 days. So you add that to this one, you should get 366. So that is basically what it's saying, maybe? I think I'm confusing myself. The number of days for which there's at least 11 hours of daylight is what? So, okay, let's just do this in that case. Easy. Well, I think 1 period is a day in this case. Because if you look at here, so 2 pi over, what's the period here? It's, yeah. So if you, so basically our period is 365 days. So if I graph this over this domain, and I want to basically first visually see what I'm trying to answer, and then we'll graph it and we'll look at it. So let's use our CAS. So let's write this down. 12 minus 3 cos 2 pi 365 times 2 minus 175. Okay, we're going from 1, that's equal to, I'll make sure it's all in x's, yeah. 366, make sure this is x. So graph that, we're going to go to menu, we're going to go Windows Zoom to see it. So it looks like this. So I'm just going to zoom out to see it really out. It looks like this. Beautiful. Let me take that out. Okay, this is how our graph basically looks. And so we're saying, according to this model, during 1 year, which is this, the number of days for which there's at least 11 hours. So if I draw the line 11, which is that 11 hours, these are the places where there's at least, so more than or equal to those 11 hours, basically, from here to here, and also from here to here. So I'm going to try to find the point of intersection. So that's quite easy because it's just basically solve. What is it? What do we say? Is it f2 of x? Yeah, it's f2 of x. So solve f2 of x equals 11 comma x. Yeah, we don't have to write the domain because the domain is already defined. And that gives me these two intersections. Sorry, these 2 points of intersections are these. And so let's graph out using, let's put it in our, graph it in our iPad, and let's see how this will look visually. So let's analyze it using our iPad and see what we're trying to basically solve here. So this is your x. Oh, sorry, that's, in this case, it's time. And this is your h, your height. So we can see that's a cosine graph. Why did I put that there? Let me put it down like that. Okay. Like this. This looks good. And so if I draw this cosine graph, which looks like this, nice. I mean, it's not the best, but yeah, like that. It looks like a cosine graph. I remember, why did I not start at t equals 0? Because it's not included. T equals 0 is not true. Because of it's saying we start from t is an element of all integers plus, so from 1 to 366. So this here is going to be 1, and this part at the end has to be 366. And so if I draw that line, straight line, which is that 11, y equals 11, these are the basically points. This is where we're going to have, greater or equal to, so at least 11 hours of daylight. So let's find those. So to do that, we need to find these points of intersection, which we already done. So I'm going to just write them down like that. So I'm going to write this down like this. So the first one we said was, what do we solve it? This was 103.4917. The other one was, so this one over here was 246.5083. So yeah, we want this part here. We want these parts over here and this part, and we have to add these together so we can get the overall time, day, how many days. So t equals what? So to get this part here, it's going to be basically this minus that. So 103.4917 minus 1 plus the next one. So to get the this part here, it's basically 366 minus that 246.5083. And so that gives me what? Let's do it in our CAS. Minus 1 plus 366. Sorry, 366 minus this over here. That gives me overall 221, so 221.9834 days. So these are the days. Basically, we'll have at least 11 hours of daylight, which looks like it will eliminate our answers C, B, A, all these. So it's only D and E. Now let's think about this. So I don't think you would round it up. This is what I'm actually confusing with the rounding in this kind of question, because it's saying according to this model, during 1 year, the number of days for which there's at least 11 hours of daylight. Now, you can round this up. You think you would round this up, but I don't think you can round it up, because if you round it up, you haven't reached a full day. Like, it's 222. So you want to kind of round it down to 221, because you haven't reached that full day. That's what I'm thinking of this question. Yeah, please let me know. Like, do you guys think, if you guys think otherwise, please let me know how you do these questions. But I think it's D. But I hope that makes sense. Not too bad. Question 12. Newton's method is used to estimate the x-intercept of a function. True. F of x is basically this function with an initial estimate of x0 equals 0. The estimate for x equals 3 is closest to what? What a beautiful, easy question. These questions have been coming in exams because it's new in study design. It's been coming up every time. And it's so easy to do. This is what you want to do. First, what you want to do is basically define f of x in your CAS. And then also define g of x. G of x is the actual formula for Newton's method. So we know Newton's method is basically like, x, it's x0, of course, but I'm just going to write it as x minus f of x divided by f dash of x. That's the formula. Now, if I define this on my CAS, this is very useful, because what we can do is, for example, if we want to find an f of 3, it says 3 here. This is how you would want to write it in your CAS to get that quickly. You would want to write g, g, g. Can you see how there's 3 g's? Because we want three amounts, so x3. And then you end up with, what's your initial value of x0, which is 0? And end them all. Close them. This here will give me my x3. This is a quick way to do this question. Whereas, if you do it by hand, you're going to be sleeping in the exam, so absolutely not. So do this. Let's do it. So I'm going to define f of x first, which is natural log 2x plus 1 minus 4 minus x to the power of 5 on 2. Have I written anything wrong? Just double check your function if you've written any mistake. Okay, beautiful. That looks good. And so we want to define g of x as x minus f of x and the derivative of f of x. Done. So what we said g, so 3 g's, and then sub in 0. Enter, control enter, and this here is your x3. How beautiful. So let's write that down. That's basically 1.47518, which looks like C, the closest. Yeah, so 14752. Beautiful. So 12C. Question 13. Suppose that we have two functions, f and g, with domains reals. It is known that g of x is less than 0, so it's negative, for all values of x. And f dash of x is equal to g of x. So basically, if f dash of x is equal to g of x, it means that also f dash of x is less than 0. So basically, the gradient of f dash of x is always negative. Given that f of negative 1 equals 2 and f of 2 equals negative 1, what is the area enclosed by the graph of g of x, the x-axis, and the line x equals negative 1 to 2? Easy. So we basically want to find the area from negative 1 to 2 of g of x. That's what we basically want. Now, well, this is actually easy because we know this statement here. We know that f dash of x is equal to g of x. Now, how do we integrate g of x? So if we want to integrate g of x, which in this case we want, I'll integrate g of x, but I also have to integrate both sides. Look at that. Like that. Now, if you're integrating the derivative of f, it's just going to be f of x. So this is going to just simplify to f of x. So the integral of g of x is actually equal to f of x. So basically meaning that if we integrate this, it's going to be f of x. Close bracket from negative 1 to 2. So subbing everything in, so like, f of 2 minus f of negative 1. And don't we already have these? Because f of 2 results us with negative 1 minus f of negative 1, which is going to give us 2. Which gives me negative 3. Now be careful, it's saying the area enclosed. Area is always positive. So basically make this positive. So it's actually 3. So choose D. So 13, D. Question 14. Parts of the graph of the two functions f of x and g of x are shown below, where x is measured in radians. Okay. The pseudocode below describes a simple algorithm to find the point where the two functions intersect. So we've got this whole algorithm. So let's look at what we're trying to find. Which of the following will the function intersect this return? So we want the return value. So let's try it out. So it says define intersect x0 and x1. So our initially, our x0 is going to be what? 0.6 in this case. x1 is going to be 0.8. Now let's look at it. The next thing, x is going to be equal to, so x is going to be equal to x0, which is 0.6. All right. While, so this is the while loop. So to make sure to do the while loop doesn't meet this condition, is x, which in this case is 0.6, is it less than x1, which is 0.8? Yes, it is. So now we have to complete this while loop. So now we're in this while loop. So let's look at the while loop. If if this here value is between basically negative 0.01 to 0.01, then you return x. And that's what we want. We want the return value. So before we do that, okay, let's think about it. So let's see if that here, if our value right now is between these values. So is cos x, which is 0.6, minus 0.6, is it between 0.01 and negative 0.01? So let's write that in our CAS. Cos of 0.6 minus 0.6 is going to give me 0.2253. Now that value is actually not in between them. So this is a problem. We actually have to skip this step because it's not between them. So we have to move on to the next step. So we have to end if, and then we have to do this now. So x must now equal, so we have to change our x equals x plus 0.01. So this here becomes now our new x value. So it's 0.61. And we can't end the while loop. Be careful. We have to redo the while loop until we don't meet this condition anymore. So, this is going to take quite a long time, but we're getting closer. We should be kind of getting closer. Next one. So imagine repeating everything. So, of course, x is less than, 0.8. So let's do this part here. Is cos 0.61 minus 0.61 between those. So let's look at our CAS. That's 1 here. That's a 1 here. Equal 0.20, basically 9. Now this is a big problem. Look at this. We are decreasing it by small intervals. We're not even going to reach this in the long term. We're not going to repeat this like 70 times until we meet it. It's a multiple choice question. So what I'm going to do is basically skip some values because it's just a repeating thing. So for example, this here, and we have to skip this x value, and then we have to add 0.01 again. So this will become 0.62. Redo the whole thing and redo the whole thing until this condition has been met. So what we're going to do is, to be honest, to save time, you do not waste your time repeating. Start to think ahead. Be like, okay, what about if we sub in 0.7? Because if you do it 10 times this whole thing, because you're adding 0.01, you'll reach 0.7. So let's say we did it 10 times, and now we're up to that 0.7 here. Let's say it's 0.7 here. Let's put this in our loop. Is it in here? So if what's cos of 0.7, that's gonna give me. Okay, 0.062. Now, it's still not in between them. It's still out, but we have got so much closer. What about if I do 0.75? Dang, we've actually overdone it. So, what about 0.04? I think that's gonna do it, hopefully. Perfect! This here is in between those two, from negative 0.01 to 0.01. And you can double check that by basically seeing it, if it's meeting that condition. Here it is. So that looks good. So is it this here, between this? There it is, it's true. So our value is when x is equal, let's write that down. When x is equal to 0.74, we can then return x. This is our return value. Beautiful. So this is our return value. So it's going to be D. Be careful. Do not repeat this thing millions of times. You'll be repeating this 20 times. Go quickly. See the pattern. Think ahead. Be like, okay, what about if I overthink it? So what about if I do 10 more. See if I overdo it. And then, yeah, that's what you want to do in an exam. You need to, don't waste a lot of time, please. So just be careful with that. Beautiful, that's not too bad. Question 15. A finance team at a small technology company estimates that the production cost per item is given by the rule C of n, where n is that, again, element of all plus integers. So basically like n is like, equal to 1, 2, not 0 by the way, 4, and basically like forever like that. So n is the number of items produced. The minimum cost per item is closest to what? What a beautiful question. It's actually quite easy. We can just use our function minimum in our CAS to do this. So let's do that. So what we're going to do is go on menu, go to calculus, and go to minimum, because we want the minimum cost. And so we're going to write the function. So 0.5n squared minus 37.5n plus 1900 plus 1250 n. And comma n. Now our domain we said was from 1 to infinity. It goes to infinity basically. Remember, not 0. We don't start from 0. It's saying it's integers plus, so from 1 to infinity. That's going to result me in, and press enter, control enter. So this is the value of n where basically we get the minimum cost. So subbing that into our original equation, this is our minimum cost. So let's write it down. So our minimum cost should be 1229.831. So which one looks like that? Looks like C is our answer of that one, the closest one. Let's have a try at 16. The values for two continuous functions, f and g, and the derivatives are given in the tables below. Beautiful. I think this is just one of the most kind of easiest questions because I've seen this quite a lot in past papers. What is the value of the derivative of g of f of x at x equals 0? All right. So we basically what we want to find is the derivative of g of f of x. Now, what do we know? How do we find the derivative of a function inside of a function? The chain rule. So if we want to find the derivative of some function like g of f of x, your u is going to be the inside function, so f of x. So you rewrite it as y equals then g of u, because our f of x is u. And you derive these two. So u dash is f dash of x. And y dash is g dash of u. And remember, you multiply these two. So multiplying these two together, you basically get the derivative. Now again, sub in u back in. So u was f of x. So sub in f of x. Done. This here is our derivative of this function, our ddx of g of f of x. Now, remember we want to find out when it's x equals 0. So imagine summing x is equal to 0. So this will be 0. So all the x's will become 0. So f of 0. What's f dash? What is our f dash when it's 0? Well, we know that f dash when it's 0 is going to be negative 1. So that's going to be just negative 1. So you write g dash. What is f of 0? F of 0 is 2. Now, what's g dash of 2? G dash of 2 is 3. So it's 3. And so that would result me in negative 3. So choose A as your answer. Beautiful. Question 17. Suppose for three events A, B, and C, the probability of A given B is equal to 1, and the probability that C and B is equal to probability of C. Which of the following statements about A and B must be true? Okay, we're giving so much stuff here. So let's actually simplify these here. Let's simplify these, because when I'm looking at them right now, I don't understand what the hell's happening. So we know given, we can simplify this as probability of A intersection B divided by probability of B, and it's going to be equal to 1. So multiply both sides by probability of B, we get just basically this. So that simplifies to that. Okay, that's nicer to look at. Now what about also this? Let's do the same for that one too. I'm going to use a different color. Probability of C intersection B over probability of B is going to be equal to the probability of C. So multiplying both sides by B, we get times probability of B. Jackpot! What does this remind you of? if the probability of C times the probability is equal to the probability of C in section B, this means that C and B are independent. This is our independent rule. So that is a hint we already got. So C and B must be independent. This is good. You've already got a jackpot. All right, so that's all we can say. So which of those statements about A and B must be true? So the first one is the probability of A must be equal to 1. That's not the case. Because it's saying must be true. So look at this here, over here. If you look at this over here, this function. Now, if they were dependent, if the following equation here, if A and B are both independent, then it is true. Then this must be true. But because they haven't told us it's independent, it's not certainly true. It depends. If it was dependent, then it is true. But yeah, it's this one we're talking about must be true. So, for example, if these were, let's say the function was, A and B are independent, it means that this whole formula works. And so if the probability of A is equal to 1, what does that mean? So if this is equal to 1, then our function works, our original function, this over here. So this here only works if they were independent. And that's a case, that's a certain case. It's not always true because sometimes they're not independent. So yeah. Absolutely. So this is wrong. This only works if they were independent. Next one. C is a subset of B. So basically, C goes into B. C is like inside of B, basically. Rubbish, actually. Wait. C and B are independent. They're not anywhere related to each other. How can C be inside of B? Like, C is a subset of B. Absolutely wrong. C and B are not even related to each other. They have no common interest. No, actually, they're all, they're independent. So there's no relation between them. So C cannot go into B. Next question. The probability of A cannot equal 1. Yes, it can. Like we said, if they were independent, it can equal 1. So not C. D. B and C are independent events. Great, we said that. So C and B are independent events. And B is a subset of A. Now I'm just going to put a question mark here. So we'll come back to it. What about E? B and C are not independent. Rubbish. So D has to be answered. Remember, we said B and C have to be dependent. It is. They are independent. So it's D. Now let's look at this. B is a subset of A, meaning that B is inside of A. So if you draw like a nice diagram here, say this is A, and this here is B. So B is contained in A. In other words, it's in other words for B is contained in A. So B is inside of A. Now, which one here tells us that it is this? Do we have any? All right. This here tells us that they are that B is a subset of A. So think of it like this: the probability that A intersection B. So when these two intersect, it's equal to the probability of B, which is the one that's being in there. So yeah, this here tells us that B is a subset of A. That's a little bit confusing, but yeah, so it looks D. D looks nice. Not too bad. 18, so we try this. Let f from 0 to 2 pi f of x be this, where a is greater than 0. There is a unique solution, f of x equals 1, and a unique solution for f of x equals -1. The minimum possible value of a is what? So let's think about it. Unique solution. That tells me that f of x, which is our graph here, intersects y equals 1 at only one place. Unique means once. It's very unique. And also, it also intersects at y equals -1 only at one place. Unique solution. If it intersects it twice in those lines y equals 1, then it's not unique. So that's what we basically want to do. And that's actually quite easy because it says find the minimum possible value of a. You're given 5 options, so you can actually sub them in, look at your CAS and see if they do intersect. So let's do that right now. So go on our CAS and let's graph them. So graph cosine a times x plus pi ln 6 from 0 to 2 pi. 0 to 2 pi. Beautiful. And so we get this graph and we get a slider. Beautiful. And also we draw the line y equals 1 and the line y equals -1. Here it is. These are the two lines. Now, basically, the graph should only intersect them once for each of these lines for them to have a unique solution. So let's look at the first value, which is basically 1 on 12. Let's say. are rubbish. This one doesn't even work because it doesn't even intersect any line. It doesn't even intersect the y equals -1 line and even that y equals 1 line. So this one has no even solution. It has no solution. So it's not A. What about B? So B states that it's 5 on 12. 5 on 12. Okay, this looks promising. You can see that it does intersect that y equals -1 line, but it doesn't intersect this y equals 1. So there is a unique solution for y equals -1, but not for 1. So that doesn't make sense. Let's just double check that and say maybe it is. No, it's not. It's not intersecting that. But we know that there's going to be an intersection point over here for these two. Look, there it is. So absolutely wrong. What about the next one? 5 on 6. All right. So there is a point of intersection for. There is a unique point of intersection. So it touches it once on that y equals -1, but it doesn't touch anywhere from the y equals 1 line. Doesn't even have a solution. So look. Doesn't even have it. So if I go to intersection, doesn't intersect that y equals 1 line, the graph. So it doesn't actually have any solutions for f of x equals 1. So now let's do D. So A, B, and C are all wrong. What about D? 11 on 12. Aha, this is actually looks perfect. So it does, touch the y equals -1 line at 1. So that's one unique solution. And it's also touching the line y equals 1 at one part here. It's not touching here, remember? Because it's not actually on it. So look, if I go to intersection. Look, it doesn't touch here, but it's touching this. That's one solution for the y equals, f of x equals 1. And also over here. There it is. So this is good. So D looks like our answer, but let's just also check 17 on 2. Why it's not that. So 17 over 12, sorry. And looking at this one over here, look, we have a unique solution here. Yes, it's, equaling f of x equals 1, so it's not equal here, so that's good. But there's a problem. At f of x equals -1, there is no unique solution. It intersects it twice, here and here. You can see that. So if I go here, there it is. Yeah, it intersects it twice. So that our answer is basically D. So let's do that. 18 is D. What about 19? 19. Let f be or reals be a continuous and differentiable function. Part of the graph of f of x is shown below. The stationary point of f of x is this and that. Okay, so we're given it here. The solutions to this inequality of that, the derivative of dash of x is greater than 0 is what? So normally when I get these, I basically graph them and solve them like this. And let's do that here. So can we basically, normally I like to factor them out. So let's factor this out. So x, 2 to 1. So if I want a negative here, it's at -2 plus 1. So 1 minus, yep, that works, beautiful. So we can factor this to be x minus 2, x plus 1, and f dash of x. What's f dash of x? So we're already given our original function f of x. Now, how do you get your f dash of x? Isn't it quite easy? Because we know that when you derive it, the stationary points, these stationary points become our x values. That's going to be here and here. And because it's like a cubic, so when you derive it, it's going to be a quadratic. Now, how is this quadratic going to look? Well, look at this. We know the gradient of this is negative from here to here. So it has to be below the x-axis for our derivative. So it's going to look like this, basically. Like that. And it makes sense. From here to here, it's positive, and that's why it's up here. And then after that, it goes negative again. So that's why it's below here. Beautiful. So this here is 3, and this here is -1. So we can see it's a negative parabola. So we can also write this. So we got these x values. So we can write those as like x minus 3, x plus 1. And it's negative, so I'm going to put a negative. Now, of course, there's a constant like a. So like negative a. Now, we don't worry about a because it's greater than 0. So it doesn't matter if you have a dilation. It's just negative a. Just put a negative here. Yeah, so that kind of describes the graph of this, and we want it to be greater than 0. So we know this part here is that line and that negative because it's a negative parabola. That makes sense. Have I made any mistakes? So greater than 0. So I can see that also. So these are multiples. So I'm going to make sure that this is going to be a squared factor. So like that. X minus 3. And now we can easily graph this. So let's graph this. So we know it's going to cross at what? So 2 here, 3 is here, -1's here. So it's going to basically cross like this. So it's going to go, and it's negative, remember? So it's going to start like this, going to pass through this, it's going to pass through this, And this here is going to be reflected because it's a multiple root. It's going to look like this. So when does this graph over here be greater than 0? Well, it's only for this section here. It's this section over here that is greater than 0, which is basically from 2 less or equal to x less or equal to 3. So that is our answer to less or x less or equal to 3, which looks like C. What is the question? 19C. Beautiful. Last question, 20. Let f be f of x this, where, okay, domain's all reals, and g of x be from 0 to 1, g of x is that. So basically, it's f of x just translated, a units. For all real values of a such that, find all real values of a such that g of 0 is the absolute maximum value of g. This is quite easy because, using your CAS, sub in these values, see which of those, tells like play around with this. Let's do this question with our CAS. So what we're going to do with our CAS is basically define this function, graph it, and play around with those a values that are given in our answers. So like the first part, let's see if that makes sense. Is g of 0 the maximum? If it's not, then cross it out and just do it one by one, and let's basically take eliminate them. This is actually, for the last question, this is nice. Let's smash it. So I'm going to go to my calculator. I'm going to define them. All right, so f of x is going to be defined as x squared times 1 minus x squared. G of x, divide right? Yeah. G of x is defined as f of x minus a. Beautiful. So now graphing g of x from the domain from 0 to 1. Beautiful. There it is. And we put a slider. There it is. I'm going to zoom it in. Okay, this is it. Move that there. Okay, this is what it looks like. Now let's check the first value. Let's go back to our iPad. So we're going to check the value where a is basically root 2. So root 2 and negative root 2. We're going to check these if these basically give us that at g of 0. So the y value is the most highest. It's that most maximum value. So let's do that. Let's sub it in our CAS. So it's going to be, so I'm going to try root 2 on 2 first, the positive. And this is perfect. You can see the maximum is actually at g of 0. And what about the negative one? So it's the same value, but negative this. Also the case here, we can see that the maximum is occurring at g of 0. So this a is actually a possibility. So we can put a nice tick on this. We can put a tick on that. Now, let's go check the other case where basically we're saying a is between negative root 2 to root 2. And so what I'm going to do here is I want to make sure this is the values that we want to play around between these. So let's do that. Work CAS. So I'm going to say here, we want this to be from, root 2 to 2. And then, so these are the values that we're going to play around. So looking at this, so for B, wrong. See, you're shifting it between those values. You can see that the maximum value is not at g of 0. Yeah, so B is wrong. So I'm going to cross B out. Let's check the next part. Well, the other part, I'm going to check one part. So for C, I'm going to check this part over here first. Let's check if this makes sense. So from negative infinity to negative root 2 on 2. So negative infinity, I'm going to say like negative 2. And then this is negative root 2 on 2, which is basically a negative here. Enter. Let's see what happens here. So, oops, what happened there? Okay, so, okay, perfect. You can see that it's at maximum. So if I decrease it, still a maximum. It's just translating down. Going more, still maximum. I think it's just, yeah, it's if it goes to infinity, it's just becoming always maximum. It doesn't matter. It's always going to be that maximum at g of 0. So that's good. So C looks good for the first part. Now we're going to check the second part. So coming back to our iPad. So this here part is great. Now we're going to check this part, which is basically saying from root 2 to 2 to infinity. Let's do that. So basically, if I make this like 2 basically, and this here, root 2 and 2. Let's graph this. Okay, so we have this. Okay, rubbish. You can see that the maximum doesn't occur at g of 0. So that part now ruins it for us. So this here is wrong. So C becomes wrong. Now let's try D. So we're going to try the first part, of course. Let's try always the first part, which is this part here. So it's from negative root 2 on 2. So basically this becomes negative here to negative 0.5. So let's try this out. So playing around this, wrong. You can see that the maximum value does not occur at g of 0. So that's also wrong. So D is also wrong. Now what about E? Wait, so for E, this part we know it's correct. It's the same as this part here, negative infinity to negative root 2. So that's correct. We're just going to check this part here, which is 1, like half to root 2 on 2. So let's do that. Root 2 on 2 to half. All right, let's try that. Okay, so the maximum value is, at 0. So if I play around, still good. If I go backwards, still good. Wait, so 0.5. Okay, so it's still a maximum, but I think the maximum occurs at 2 points here. So if I go maximum, so it occurs still at g of 0, but also it occurs the same maximum point at also 1. But that doesn't matter. Still, it does occur at g of 0. That's the main point of here, because we're trying to find the real values, all those real values of a. So still, yeah, it still occurs at g of 0. This one looks actually good. Like playing around with this, you can see that, yeah, it is, it's always maximum. So E looks correct. So basically, E is our answer. So A is correct too, but the problem with A, it doesn't state all the values of A. So, and yeah. Perfect. I hope you guys enjoyed this video and learned something from this video. I did take it very slowly, try to go as much detail as I can. I hope you guys enjoyed this video. Please make sure to like and subscribe for more future videos like this, and good luck to all people. I hope you guys have a great day. Bye-bye.